Let's find out the derivative of the following. To begin with, we will consider u to be equals to sine inverse of square root of 1 minus x squared. And we'll consider v to be equals to cotangent inverse of x divided by square root of 1 minus x squared. So what we have to find here is we have to obtain derivative of u with respect to v, whereas u and v are given in its parametric form. Now, we will need to obtain derivative of u with respect to x, but before doing that, we will try to simplify the expression on the right side of u using a trigonometric substitution. So let's suppose that x be equals to cosine of theta. Then u will be equals to sine inverse of square root of 1 minus cosine squared theta. And we know that 1 square root of 1 minus cosine squared theta, so that simply equals to sine theta. Here we have used a property, an identity actually, which is cosine squared theta plus sine squared theta. This value is equals to 1, which gives us u equals to theta. We have considered x to be equals to cosine of theta, so that means theta will be equals to cosine inverse of x. So we have u equals to cosine inverse of x. So let's label this as number 1. We'll take its derivative with respect to x after simplifying v as well. So for v also we can make a substitution. So here we are going to consider x to be equals to cosine of phi. So that makes v equals to cotangent inverse of cosine of phi divided by square root of 1 minus cosine squared phi. Now, this will be cotangent inverse of cosine of phi. So square root of 1 minus cosine squared phi, this will be equals to sine phi. But here also we have used the same identity, but instead of theta we have phi. So cosine squared phi plus sine squared phi. So this value is also equals to 1. Now v will be equals to cotangent inverse of cosine over sine. So this ratio is the cotangent function. So we have cotangent of phi, and cotangent inverse of cotangent of phi is simply equals to phi. Since we have considered x to be equals to cosine of phi, so phi will be equals to cosine inverse of x. So that means v will be equals to cosine inverse of x. So let's label this as number 2. Now that we have u and v, we will take its derivative with respect to x. So derivative of u with respect to x, so this is a standard derivative with a value negative 1 over square root of 1 minus x squared. Similarly, derivative of v with respect to x is also going to give us negative 1 over square root of 1 minus x squared. To find out derivative of u with respect to v, all we have to do is take the derivative of u with respect to x and divide it by derivative of v with respect to x. Since we already have the value, this is going to be equals to positive 1. So that means the value of the derivative, which is equals to 1.